Okay, so apparently my video crashed halfway through last time. So once again, for the second time, we are talking about section 8.4, which is calculating the area of annuluses, sectors, and segments. So first off, take a second, pause the video, and write down those words in your notes along with the picture of those things. So a sector is this shaded area, looks like a piece of pizza. The segment is this shaded area. It's like you drew a line through the circle and it's the piece you cut off. And an annulus is this circle with a circle removed from the middle of it. It's the donut-shaped part. So pause the video, draw those, then start it again. So before I actually give you the official formulas for these, let's just talk about what you might do for some of these to actually find the area. Hopefully the annulus is pretty straightforward. You can kind of think about how you might do that. We're going to take the area of the big circle and just subtract the area of the small circle to get the area of our little donut-shaped piece. That one's not too bad. You probably wouldn't even need a formula for that one. When we talk about the sector of a circle, you can look at this in kind of like a piece of a circle or a fraction of a circle. And so what we're going to do for these is we're going to take a fraction times the area of the circle, whatever fraction that would happen to be. If it's 1/5, 1/2, 2/3, whatever it is. The segment is definitely the hardest one here, and we're actually going to have to do this as kind of two steps. What we're going to do is we're going to actually take the area of an entire sector and subtract off the area that we don't want, which is the area of the triangle, and what's left is the area of just the part that we want at the top. So that one's going to be a little more complicated, but we'll look at that one. And so if you're actually looking for formulas, which I'm sure you are, here they are. You can see down here, we have this fraction, a over 360. That's the angle in the middle, the central angle you could call it, over 360. That tells us the fraction times the area of the circle. For the segment, we've got the area of the sector. It's the same formula as over here, minus the area of the triangle, 1/2 base times height. And then for an annulus, we've got the area of the big circle minus the area of the small circle. Capital R is always going to be the radius of the big circle. Lowercase r is the radius of the small circle. So again, pause the video if you need to write those down, and then we'll do a few examples. So first one we've got here is a sector. We've got 45 degrees, 20 centimeters for the radius. And so I'll go ahead and write down the formula. We've got a over 360 times pi times r squared. I'll plug in what I know, 45 over 360 times pi times 20 squared. So at this point, there's kind of two options of how to do this. You could do it as like you probably would have traditionally learned this, which is to simplify, little step by little step using your order of operations. So we'll do that first. If you're doing that, you're going to want to do your exponent, which would be 400. 20 squared is 400. You'd also want to simplify that fraction, which is 1/8. 45 goes into 368 times, and we've just got pi stuck there in the middle. We can't do much with that. 1/8 times pi times 400. And then the last step you'd use here is you'd know that since it's all multiplication, the order you do it in doesn't matter. So I can just take a 1/8 times 400, or 400 divided by 8. That's the same as times 1/8. And say, okay, well, 400 divided by 8 is 50. I've still got my pi, and I need my units, centimeters squared. We are going to be leaving these in terms of pi, so we're going to leave that there. Now, the other option you have is to use a scientific calculator. A scientific calculator will let you not have to worry about simplifying a lot of this stuff on your own. Is it going to crash again? That is the question. Hopefully it does not. So, got my scientific calculator. If I don't want to, I could use the scientific calculator to simplify, all that fun stuff. If I take 45 divided by 360, it will simplify that for me into 1/8. But what I can do here is, again, since this is all multiplication, it doesn't matter if I just leave the pi at the end. And so I can do 45 over 360 times 20 squared. And that tells me that's 50. I've just left the pi at the end. I've left the pi out. It's almost like there's a pi sitting right here at the end. I've just not actually multiplied it by pi because I want to leave it in terms of pi. So that's kind of the easy way to use a calculator to help you out. Leave the pi out of it, put it in at the end. As long as it's all multiplication, you can do that. you can just move the pi to the end and do the stuff at the front, leave the pi at the end. Okay, next one we've got is a segment. And so for the segment, we've got the area formula of basically the same area formula as before, 360 pi r squared, or a over 360 pi r squared. And then we're going to subtract the area of the triangle, 1/2 base times height. And so I'm going to do this in two colors because we're going to basically just treat these as two separate things that we'll subtract at the end. So my angle here is 90 degrees over 360 times pi. My radius is 6 squared. Then the area of this triangle, since it is a right triangle, I can use that as my base and that as my height. So minus 1/2 times 6 times 6. Okay, so I'm going to do these two separately. On this one, we can just grab, again, a scientific calculator and type it in. You could always simplify by hand. That's nothing wrong with that. But this isn't simplifying class, it's geometry. So use technology. So I'm going to go ahead and type in that first part, 90 over 360 times 6 squared. I've just moved the pi to the end. And so I've got 9 pi. And then if I wanted to, of course, I could use Desmos to help me out on the second part. 1/2 times 6 is 18. And so I've got 9 pi minus 18. I could leave my answer like that with just a centimeters squared at the end. That would be great. The other option I have on these, and I'm going to let you leave these as decimals. If you have it to leave it as a decimal, you can just type in exactly what you see here and get an answer. 90 over 360 times pi, either type pi or use the pi symbol, times 6 squared. Again, you can use that button there. Minus 1/2 times 6 times 6. And so my answer in a decimal form would be 10.27. The one thing you can't do, you cannot just leave the pi out and try to get an answer in terms of pi. That will not work because these are not like terms. This one has a pi in it. This one does not have a pi in it. You can't just subtract those. You have to have the pi in there to get an actual number minus an actual number. You get some very weird answers if you leave the pi out. Okay, so there are your two options there. For those, I'd be perfectly fine with the 10.27. There's nothing wrong with that. On the quiz, it says you can leave those as decimals. Last one is a working backwards question, and I have to change this because this didn't work. Should be 12 pi. So I've got the area of the sector is 12 pi. Find x, which is the angle. And so I'm going to start by writing my formula down. Area equals a over 360 times pi r squared. And I'll plug in what I know. The area is 12 pi. I don't know the angle. That's x. Times pi, and my radius is 6. So when we're solving this equation, there's a few different things that you could do here. Ultimately, it's just a matter of undoing the things that you're seeing. And so there's multiple ways. Let's talk about one nice way you could do this. The first thing you could do would be to divide by pi on both sides. That would cancel that out, cancel that out. So I'd get 12 equals x over 360 times, and I might as well do 6 squared and get 36. At this point, one really nice option is to multiply both sides by 360. I've got this divided by 360. Let's multiply by 360. 12 times 360, not something I know off the top of my head, is 4,320. So I'd have 4,320 equals, well, I just have x times 36 left, so that'd be 36x. And then I can just divide by 36 on both sides. Again, calculators are nice, so I take that previous answer divided by 36, and it says 120. And since I'm talking about the angle, that is 120 degrees. So that is one way to do it. I like that way. We did it a different way in class, but it both works. I think this way is nicer. And so there you go. Your homework here is on page 426. You're doing 1 through 12. These first ones are all just finding the area. And then back here, you've got somewhere you have to, there you're solving for the radius. This one's finding the area. They tell you the radius there. This one you're solving for this radius. Oh, no, sorry, this one's wrong. This one, R is 2. So you're finding the area, you're finding the area. Here you're finding the radius. Here you're finding the radius. Here you're finding x, just like we did before. And then 12 is definitely the hardest one. You're finding that angle to make this little chunk of the annulus 10 pi square centimeters. So give that a shot. You'll have to do a little critical thinking there to figure that one out. That'll be a good challenge. So I'll see you tomorrow then.